All right, for this quadratic equation, I ask you to specifically use the completing the square method to solve it. In order to do that, we're going to separate out the variable parts from the non-variable parts. Now, we've been doing it in class just by leaving space between those, but if you'd like, you can always bring that negative 85, you can add it to both sides, and you could have a positive 85 on the right-hand side of this equation. It's up to you. I'm going to leave mine where it is just because that's how we've been doing it in class. All right, next I want to turn this into a perfect square trinomial. First problem though, I've got a coefficient, so I need to factor out that coefficient. At this point, I need to ask myself, what should I add to turn this entire thing into a perfect square trinomial? I know I need to take my b term, cut it in half, and square it. So negative 1 squared is positive 1. So I'm going to add 1. This is now a perfect square trinomial, and I can prove that by writing it like this. And I can always double check. If I distribute this, negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. But I didn't just add 1. I really added 10 times 1. So I need to subtract 10 immediately. Now again, if you've got your constants on the right-hand side, then you're just going to have a positive 95 on the right-hand side. We'll get there in 1 second if you're doing it like we've done in class. Come on, pen. There we go. Okay, at this point I can add 95 to both sides. Divide both sides by 10. Now if you want, you can leave it as 95 tenths. You could write it as 9.5, or you could find a common factor and reduce this because we know that 5 goes into both the numerator and denominator. So 95 divided by 5 is 19. 10 divided by 5 is 2. So you can leave it as 19 halves. I'm also fine if you write it as 9.5. Whatever. That's what it is. Then take the square root of both sides plus or minus the square root of 19 halves. And since I'm running out of space, I'm going to rewrite it up here. So we had x minus 1. Oh, my pen's weird. Equals, hang on, why is it so gross? Let's try it again. Well, it's just going to be messy. You'll have to deal with it. Plus or minus the square root of 19 halves. Add 1 to both sides. X equals, let's see, 1 plus or minus square root of 19 halves. Sorry that the pen is being weird. This is the first time I've used this app. Alright, so one answer is x equals 1 plus the square root of 9.5, or 19 halves, or x equals 1 minus the square root of 9.5. And those are my two solutions. Now if I wanted to check that the solution works, I need to take this entire amount and plug it back up in wherever I see an x. I'm going to let you take the time to check that it works. But this is how I would list my solution. And for the love, I don't know why this pen doesn't want to work. 1 plus or minus the square root. And again, you can leave it as 9.5 or 19 fifths. I can't get the pen to write it all, so whatever. That's supposed to be a 9.5. I hope you have been following along and can keep track of that. There we go. And I can't put my mouse. There we go. That was way harder than it needed to be. Okay, so you can just leave it with the square root like that. Please do not put that into your calculator and give me a decimal approximation. That's gross. I want exact answers, which means leave it as a square root of a fraction, or in this case, since it's a nice square root of a decimal, this decimal is fine, but do not put that in and then estimate, to the nearest hundredth or anything. This is exactly what I want.